Hello students, we will go to another example of vector field. So, example, plot the vector field. Vector field f of x comma y equal to xi plus yj divided by square root of x square plus y square. So again this can be written as x by square root of x square plus y square times vector I plus y divided by square root of x square plus y square times vector j. So this is m of x comma y and this is n of x comma y. So mi plus nj. Again this is a vector field in the plane. So let us draw the plane, x-axis, y-axis. Now what is the domain? Domain is not given to you. So domain is the largest possible subset of the xy plane such that these expressions for m and n make sense. But when x comma y equal to 0 comma 0, then x square plus y square is 0, denominator is 0, so it doesn't make sense. So at the origin it is not defined, and at every other point it is defined. And what is the modulus of this vector field or absolute value of this vector field f of x comma y? F of x comma y absolute value is square root of m square plus n square, right? M square plus n square. So what is m square? It is x square by x square plus y square plus what is n square? It is y square by x square plus y square, then square root of that. So what you will get? This is equal to 1. So at the origin it is not defined, but at every other point you have to draw a vector whose magnitude is equal to 1. And in which direction? In the direction of the vector x comma y. In the direction of the vector x comma y, because the direction of the vector x comma y is the same as direction of this vector x comma y is the same as direction of x by square root of x square plus y square vector I plus y by square root of x square plus y square times vector j. This x comma y can be written as xi plus yj. So direction of xi plus yj is the same as direction of this vector. So at every point x comma y other than 0, you have to draw a vector whose magnitude is equal to 1 and whose direction is the same as the direction of the vector x comma y. So if this is the point x comma y, at this point draw a vector whose magnitude is equal to 1. If this is the point x comma y, then at this point draw a vector whose magnitude is equal to 1. At this point draw a vector whose magnitude is equal to 1, and so on. So it will be radially outward, but all are of the same magnitude. Magnitude is equal to 1. And so on. Hope you understood. We will plot another example of a vector field. plot f of x comma y is equal to 1 into y plus 1 into j. Okay, so this is your m, and this is your n, namely n equal to 1. So again, this is a vector field in the plane, and m and n are defined everywhere in the plane. So at this point you have to, this is the point x comma y, you have to plot the vector 1 comma 1. What is the vector 1 comma 1? 1 comma 1 is this vector. So at this point plot this vector. At this point also you plot this vector. At this point also you plot this vector. In 0 also you plot this vector. So this is an example of a constant vector field. Constant vector field. Means m and n are constants. It's an example of a constant vector field. Another example, f of x comma y equal to yi minus xj. So m of x comma y is y, and n of x comma y is minus x, and I have to plot this. So how do I do this? Take some sample points, and what is the domain? Domain is all points x comma y in the plane such that the expressions for m and n make sense. But at every point in the plane, m and n makes sense. So the domain is the whole plane, and we shall plot some sample points. F of 0 comma 0, it is again 0 comma 0, 0 I plus 0 j, and what about f of 1 comma 0? F of 1 comma 0 is yi minus xj. So 0 I minus 1 into j. So it is actually the vector 0 comma minus 1. So at 1 comma 0, what is the point 1 comma 0? This is the point 1 comma 0. You have to plot the vector 0 comma minus 1. But 0 comma minus 1 is this vector. This vector. That vector you have to plot at this point 1 comma 0. So you will get like this. Okay, I can erase this part. I don't need this. Okay. Now take another point. Let us say f of 0 1. So it is 1 into I, 1 into I minus 0 into j. So it is 1 comma 0, 1 comma 0. So at the point 0 comma 1, what is 0 comma 1? This is 0 comma 1. I have to plot the vector 1 comma 0. What is 1 comma 0? It is this vector. So translate this vector to this point without changing its magnitude and direction. So you will get like this. Similarly, f of minus 1 0 is 0 into y minus 1 into j. That means 1 into j. So it is 0 comma 1. So plot that vector at the point minus 1 comma 0. This is minus 1 comma 0, and at the point minus 1 comma 0 you plot the vector 0 comma 1. Which is 0 comma 1? This vector. So translate that vector to this point without changing its magnitude and direction. So you will get like this. Similarly, at this point you will get like this. Does it look beautiful? What about this point? Suppose I am taking an arbitrary point x comma y here. That is the input point. And what is the output point? It is y comma minus x. Look at xy, the point xy, and look at the point y comma minus x. So I'll write here x comma y. This is the input vector, and what is the output vector? It is y comma minus x. You take the dot product between them. What you will get? So it is x into y plus y into minus x. It is xy minus xy equal to 0. That means the output vector is orthogonal to the input vector. The output vector is orthogonal to the input vector. That means this is the input vector x comma y. This input vector, this is the input vector, and the output vector is orthogonal to the input vector. So the output vector must be something like this, translated to this point. Okay, because this vector and this vector are orthogonal. Another chance is this is the input vector, output vector can be like this, and these two vectors are orthogonal. Which two vectors? This input and this output vectors are orthogonal. So which one? I have to take this one or this one. But from our experience, it shows that I have to take this one because it is a clockwise rotation. So I have to take this output vector and I have to translate that output vector to this point. So that will be the plotting of the vector field. Okay. So let me translate this vector to this point without changing its magnitude and direction. So what I will get? I will get this one. Remember, the magnitude of this line and magnitude of this line, they are the same, because for the input it is x comma y, and for the output it is y comma minus x. So magnitude of x comma y and magnitude of y comma minus x, both are the same, and is equal to square root of x square plus y square. Okay. Similarly, at this point you can plot. So it will be like this. At this point you can plot. So it will be like this. At this point it is like this. So clockwise rotation. So you can think of something rotating around the origin. At the origin there is nothing because it is 0, 0, and the output is also 0, 0. So something rotating around the origin, that is the vector field. നമ്മൾ ഒരു പാത്രത്തിൽ വെള്ളം എടുത്തിട്ട്, ഒരു ബക്കറ്റിൽ വെള്ളം എടുത്തിട്ട് ആ വെള്ളം അങ്ങനെ ശക്തിയായിട്ട് കറക്കുക. അപ്പോൾ സെൻറ്ററിൽ റൊട്ടേഷൻ ഒന്നും ഉണ്ടാവില്ല. മറ്റു പോയിന്റ്സുകളിൽ വെള്ളം അങ്ങനെ ശക്തിയായിട്ട് കറങ്ങിക്കൊണ്ടിരിക്കും. ആ വെള്ളത്തിൻ്റെ വെലോസിറ്റി വെക്ടറാണ് ഇപ്പോൾ ഞാൻ വരച്ചത്. ഒരു ടിപ്പിക്കൽ പോയിന്റ് എക്സ് കോമ വൈ എടുത്തു കഴിഞ്ഞാൽ ആ വെള്ളത്തിൻ്റെ വെലോസിറ്റി വെക്ടറാണ് ഞാനിപ്പോൾ എടുത്തത്. Thank you.